We're looking at section 7.5, and we're reviewing some of the word problems from the previous sections, just so you can see the setup and help you study for your test. So number 26 was a problem where we were depositing money into an account at an annual interest rate of 4%. Notice it does not say continuously compounded. So for this type, we use the A equals P times 1 plus or minus R to the N. We use this formula when it is money growing at some rate or depreciating at some rate. And we need to remember we have 1 plus the rate of change inside the parentheses. So the P is our initial amount, 1 plus our rate. The rate is written as a decimal and then raised to the number of years. So I've worked out A, B, and C. Please take a close look at C, because in C we're solving for the number of years. So we have to do some algebra for that one with some logs. Number 27, write an exponential function to model each situation. Find each amount after the specified time. So here we have population growth, growing again at 1.2% for 15 years. We need to remember when we put in the growth rate, it is 1 plus the rate. So it's 120,000 times 1.012 to the 15th to get our solution. All right, so number 31 is another investing of money, but it does say compounded continuously. When we see compounded continuously, that means we need the PERT equation, A equals P times e to the RT. Please remember to keep your 0.052 times 5 in parentheses when you enter it into your calculator. It should look the way it looks on my screen. Here is another financial interest rate problem, and this was kind of a neat problem where they were giving us 2 different banks and comparing them, so please look through that. You can see how I went about that one. That is still looking at principal times 1 plus R to the N. And here is a pH problem, and they give us the equation for pH. pH measures how basic or how acidic a substance is, and pH is equal to the negative log of the hydrogen ion concentration, the H+. These are pretty straightforward. You are usually given the H+ concentration, the hydrogen ion concentration, and then you just have to do the negative log of that number. So for apple juice, we have pH equals negative log of the H+, which is negative log of 3.2 times 10 to the negative 4. Please remember how to put scientific notation into your calculator. To get the times 10 to the negative 4, we do second comma. So negative log 3.2, we would use second comma to get times 10 to the negative 4, and we get 3.495, showing that it's acidic. So a level that is greater than 7 is basic, a level less than 7 is acidic, and 7 exactly is neutral. And here is the example with the intensities of earthquakes to determine how much stronger one earthquake is than the other. On this formula, we want to remember the higher number should go in the M1 variable, and the second earthquake should go in M2. We've done a few of these, so please look this over. Isolate the I1 over 2, and then you can multiply the I2 over, and we see that I1 is 10.16 times I2. 10.16 is 39.81, so it's 39.81 times stronger than the first earthquake. And then finally, we have a loudness problem. On this one, loudness is equal to 10 times the log of the intensity of the sound we're listening to over the intensity of the quietest sound we can hear. Just remember, when you put this in your calculator, the 10 to the negative 12 should be put in as 1 times 10 to the negative 12, and 1.65 times 10 to the negative 2. Again, on these, you would need that second comma on your calculator to get the times 10 to the. And what I have done is I've worked through each of the example problems in 7.5. The first example, what is the solution to 16 to the 3x equals 8? Well, both 16 and 8 can be written as a power of 2. So we rewrite 16 as 2 to the 4th, and then to the 3x, and we rewrite 8 as 2 to the 3rd. Then we have 2 to the 12x equals 2 to the 3rd. Once we have a common base on each side, we can set their exponents equal to each other. So 12x is equal to 3, and we get x equals 1/4. In this one, we do not have a common base, so to solve an exponential where the variable is in the exponent, we take the log of each side. You can use log base anything you want, but your calculator has log base 10 buttons, so I chose to do that. So I took log base 10 of each side, then I used the log property to bring the 3x down in front, and then I divided both sides by log 15. That number you get on your calculator, log of 285 divided by log 15 equals 2.087, and then we solve for x by dividing by 3. All right, here's another application problem. This was the lumber company has 1.2 million trees. They plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? So half of the trees would be 600,000. We need to remember that we are decreasing the number of trees by 7%, so we would say 1 minus 0.07 in our b variable, 1 minus 0.07 to the n. And once we have our equation set up using y equals a times b to the x, we isolate the exponential, and then we take the log of each side and get n by itself. All right, so now we're going the other direction. We're solving a log equation. And when we do this, we want to isolate the single log. We want to get one log on one side. That means log is only written one time. And then use any properties we need to, and then change the forms. So this already has a single log on the left side, so we can change the form. This is log base 10. So we can say 10 to the second equals 4x minus 3, which is what we have here. 10 to the second is 100, and then we just solve for x. Add the 3 and divide by 4. Problem number 6. Here you see that we have 2 logs on the left side. We need to condense that using log properties, then change the forms, and then solve. So we condense this, writing this as a single log, by noticing that addition can be condensed to be multiplication when we write it as a single log. So this is the log of x minus 3 times x equals 1. Now we can change the form because this is log base 10. So 10 to the first equals x squared minus 3x. Get everything on one side, which is what we have here, and then factor. And then remember to check your answer. And you should, it is the best idea to check your answer in the original equation. And when we do that, we get log of 5 minus 3 plus log of 5 equals 1. That one comes out to be true. But when we plug in negative 2, we get log of negative 2 minus 3. And we cannot take the log of a negative value, so that one does not work. All right, and then this was the homework for section 7.5, and I put some helpful hints on what to do for each of the problems, each of the sections, how to go about them, so I hope that helps.